Hey guys, okay, I'm going to do kind of an impromptu chit-chat slash bunch space explained behind the scenes thingamajigger, and try to put some sense to what exactly a blend space is, as opposed to its perception as being limited to a particular use. Now, coming from the 3D world of 3D graphics in general, I use applications excluding putting stuff into Unreal 4 and making it work the way I wanted to. I predominantly use applications like 3ds Max and Motion Builder, or any application that can get the job done. So the idea of a blend space is, well, it's not really a technical advancement, but rather the use of something that's been around forever, and particularly in using an application like 3ds Max for doing facial type of animations, using what is no more than just a type of blend space. You can build up a rig, a gizmo widget that has all the main control points that makes up part of the whatever it is that has been attached to the character's face. So if you want the mouth open and closing and what have you, you have a slider that opens and closes it, or the eyes open and closing. You have another slider or gizmo gadget that opens and closes, and then you can create what is a two-dimensional array where you can move a key point into it, say for example to move the jaw around or open and close in various different shapes and forms, as well as correct for lip placements and what have you. That is all combined into a single widget, we'll call it that controls the entire facial operation as what would be considered a blend space. Even DAZ Studio has a thing called Puppeteer, if you want to check it out, YouTube it or whatever. The idea of being able to put your key framed animations into a slot within an array has been around for quite a while. So that's kind of the overall, let's say, explanation of just what is a blend space into itself. In other words, it's nothing more than either a one-dimensional or two-dimensional array, which you can index by an input value. And that is a benefit in Unreal 4, in that it gives you options of being able to control by data the entire progression of the animation as it moves through the animgraph. Now, the animgraph should be maintained in a position where it doesn't have to make any decisions, or make decisions based on arguments nested within the animgraph. So it's a best practice thing, so let's say. So the most common thing that has usually been kind of put out there as the preferred means of being able to move and create player movement within the stream is, of course, the use of a state machine. Now, state machines are pretty cool in itself, but it is old technology in that going back to well, the first time somebody wanted to make any kind of object move within three-dimensional space, that's always been considered as part of some form of state machine. It doesn't, they don't look like this. It could be hard-coded. It could be, but it is a progression of logic through an animation stream that attempts to match up the movement of the characters to exactly the state of the game code that's being generated. Now, this usually translates into let's say mistiming errors. Doing it this way, putting arguments into a state machine, what tends to happen is you lose the syncing of the actual required movement in relationship to what the actual code is generating as far as a requirement as to movement. So what you land up with is things like the timing, the timing of the sequence gets out of whack, and you have a player running forward at 20 miles an hour and the feet moving at like 10 miles an hour. So the feet tend to skate until you can correct the scaling of the timing of the animation, and etc. and blah 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 blah. And so to sort of set up the context, our design pathway requires a high degree of flexibility as to future demands. In other words, we have to make it do it we have to get things moving now this way, and then be able to expand it later on the things that we want to add as part of the progression. So we're not locked into a single movement system where takes a lot of work to be able to introduce new, let's say, movements or elements into the game. Almost like sitting down, having a coffee and a donut, and boom, you're done, kind of thing. So that's the way we're progressing as far as let's say, future-proofing the design that will ultimately allow the animator to just create a blend space, being a two-dimensional array, and then introducing that into the flow. So this is actually the locomotion state that we're building. So as you can see, everything starts as a head. How things, you got to get the player moving. So the first thing that we do is we set up a blend space that has all the necessary elements of how the player is moving, or how the player is orientated within three-dimensional space. So this initial setup is triggered by an integer input. So you have slots. So slot 1, slot 2, slot 3. Slot 1 could be running. Slot 2 could be crouching. Slot 3 could be in the prone position, and then everything that is evolved into as part of that, as part of the overall, let's say, package, as to 8-way movement, is contained within that blend space, and then the change is inputted based on just a simple variable. In this way, the event graph maintains the orientation of the player data as to its relationship to three-dimensional space. Is okay, and whatever code or event you set up that says, okay, the player's running, walking, falling, jumping, flying, driving, whatever, is simply a state argument. Well, it's not even an argument. It's a state based on a question. Is the player moving? Is the player in the air? This could be jumping, falling, whatever that is forked off, which is then driven by, and its current animation state driven by an input. So as to kind of progress this further as to how this logic actually works within the stream of things, why would this be a better practice in this situation where you need to have the ability to add more complex animation type of situations? Is we can introduce those types of situations within a given logic block. So in this case, our locomotion state, this state here, is nothing more than this. That is driven 100% by data input from the event graph that can be changed at any time based on whether the coder decides that he wants to grab a particular event, as to say applying physics, versus the need to well, turn off the physics and just let the animation do its thing if you're, for example, using root motion. So we're creating a logic block state as the animation progresses through to its final output over here. Now this type of progression idea is this is actually a slimmed down version of, let's say, this is one of my first iterations, slimmed down to kind of get an idea without having a whole bunch of boxes and having to explain everything, but because the logic progression is still the same, be it we have 10 tons of event changes, or if we're just having something simple and follow through. So in this case, the locomotion goes into a state which creates the initial positioning of the player within three-dimensional space, be it walk, run, crouch, in the idle state, or whatever, as to let's say the primary animation that you would create within a state machine. So from this, it just simply takes this information, drops it into a cache. So this is what this playthrough actually contains information as far as the progression at this state, which then takes this information and then it goes down here to the weapon select. This is once again fine-tuning required, really based on being able to input information of exactly what kind of weapon, and then just whatever weapon is being selected based on the index, then it triggers the appropriate what will be a single frame pose of the player model holding a particular weapon. So in this case, if the player is holding a sidearm, or if the player is holding a rifle, then this is additive to that as a per bone blend. Let's see, layered per bone, yeah, per bone, that allows the state to be changed for that index. So let's see if we can kind of simulate that quickly. So you can see over to the side here, based on idle poses and what have you. All the torso is being driven by this type of logic progression. So that once again will all be packed up into a blend space ultimately, and then it's just a single input based on this index here. Where is our output? Okay. This only has one slot at the moment. We can change this index to whatever we want. Conforms to that. We drop down here. Then we can repose the player without having to re-author a whole bunch of different types of animations for a particular weapon, which positions the hands as the proper contact points. Then that goes from there. It is to action. And then we can take that and take our to whatever action that we want to perform. Once again, logic block-wise, kind of messy. Fine-tune it. Start getting into tables and lists, and then we can now drive all of this as to a given action. So if, say, for example, the player is reloading a weapon, or the player is equipping to a different weapon, and what have you, then we can, kind of shape the animation flow to being weapon orientated rather than key positional orientated. Blah 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 blah, etc. Basically what that means is our animations are going to be driven based on weapon usage and not on just generic movement in itself. Okay, from there we just simply go up to our final output stage, which then has an aim offset. The aim offset, of course, will adopt whatever we add as far as positioning goes. So if we go into the aim offset with a sidearm, or if we go into the aim offset with a rifle, then that information is just added to as an additive to whatever current state or post position that the player's in. So that takes us into the per blend mode. Layers that on top of whatever the torso is, which is usually driven by our locomotion state, meaning if the feet is moving and the player is aiming, or aiming, that is then additive to it based on the aim offset. And then of course if we perform an action like a firing sequence, firing the gun, boom 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 boom, depending on how many cycles, is it single cycle, is it burst, or is it automatic, it goes through here, picks up that information, throws that into as an additive into our aim and offset. So if we're aiming up, down, left, right, wherever we're moving, aiming, that animation information is added to the final pose output. Over here we have we then go into our K system. There's a per socket ray trace from the feet downwards. Now this is not really active at the moment, but the information that we retrieve back from that we feed back into our event graph, which then allows us to do things like calculate how far is the player from the ground. Now if the left foot is over an edge, then we can create an event that would be true to the fact that the player's left foot is over the edge and it just doesn't float in three-dimensional space. And then that can be fed into as an event into within once again, probably in this case is the player then becomes in the air, gets into an in the air state, because anytime the player is off the ground for any reason, they are in the air as far as its world space orientation goes. And then we can just pull off another blend space into this and then index into that as to the particular action that is required for that. Okay, so that then pulls us back to here again. Not functional yet as blend space. There's a story behind that, but once we actually do get it all working and we get it integrated into the system, then I'll probably go over that a little bit more. This little bit of thing here is just a kind of a test thing. We're using root motion, and I want to be able to reorientate the player at any time within three-dimensional space, or actually in actuality the coder wants to be able to orientate the player in three-dimensional space anytime that they wish. So I'll grab the root rotation bone, which we can turn it around. Unfortunately, it doesn't have a node for things like position, translation, where the particular player is actually positioned within three-dimensional space. And then from there, boom, we go out to our final animation pose, and then of course all the variables will start to work. So the ideal situation is in no time do we go into any kind of let's say a detour within the animgraph. So when we start playing our actual character, once we actually get everything plugged in and what have you, this thing will light up like a pinball machine, and we know exactly at any given point within the motion stream where the player is orientated as a sync with whatever it is that the engine code is producing. Now, to kind of move forward and on, how you be able to test this kind of stuff, this is based on, obviously, on the logic block. How do you have to set up your blend spaces that fit within a parameter? In this case, this is our walk run, which is driven by right left and forward back, which is simply a key input based on W, and in this case I have it bound to WASD, and for forward, backwards, and what have you. And I just use other keys for strafing and direction changes and what have you. But anytime I hit the W key, it just takes the input and says, oh, forward's been pressed, boom, move forward. So that's and since it's driven by root motion, it's direct to, and there's no other let's say setup required in the event graph to actually move the character pawn forward based on wherever the capsule is orientated. So to move on forward, when should you start switching things out and start using blends or state machines? Now, state machines are great as long as you can maintain a linear flow from the input to the output that is an argument only onto itself. Where things kind of go boom is when you want to change the argument inside the blend space based on an event that, well, let's say that the event graph has trouble being able to maintain that sync. That's probably the biggest problem that you're going to run into, as probably the number one problem error that you will have is when code unsyncs from whatever it is that the animation system or your animgraph is generating as far as output goes. They are both unique, but let's say one and the same in that whatever code is being generated, particularly as to speed, has to be obviously relayed down through as part of the progression. So in this case, we want to test the idea out. If your state machine starts looking like this, then you're getting yourself into a situation where you're going to have arguments arguing with arguments, and then you can't get out of the state. Now, how this usually translates, and you can probably go to YouTube and see any game where the player's running, it's working fine, and all of a sudden the player decides to stop, and the player is still running, and what's happening there is simply that the locomotion part of your animation has got jammed up inside the state machine, and it's just arguing with itself, and it's going round and round and round and round. So if it starts looking, so if your animgraph starts looking like this, then you have you're building in a fundamental problem. Now, ideally, you go into one state. Let's say, for example, a jump in air, or start jump in air, and then you see you're getting into a landing state, and then you land and you go back out again. This type of setup here, you're starting to ping pong around your information and data inside an event graph that it becomes, well, extremely difficult to start troubleshooting, for one thing, because everything is based on an argument. Okay, we're getting into, we're getting out of, how do we move from this state to that state? So if you're looking at this can, with a blend state, can translate into this. Boom, simple, easy, as far as building the logic block progression. If you get it down to this, there's no point in using a state machine any longer, using a state machine, and you might as well put your blend space into a blend post by whatever, be it an integer, boolean, what have you, and it just adds to it directly, and then everything as it would be driven normally through the blend space, and then is translated through the variable. So what does a blend space look like in this case? I have this actually set up here. This just to kind of give a tip. I'm very good at working with logic, not very good at coding things, actually implementation, but the nice thing about blueprints is you can test the idea, and then if it works, then you can implement it without having to say, looking at, at various different options, so to speak. So with the blend space, with just putting a a state machine, building up the logic within the state machine, and then I can use that logic to actually convert whatever information I need to make this work into the actual blend space itself, which then of course is variable driven. So how to tie this into the system is quite simple. Since we are caching from one logic block into the other, we just change the pathway. If we compile, our logic is now taken, or our key locomotion is taken from the state. Now with the state machine, for example, here set up to do a blend space that represents running and walking and so forth in various different directions, which is more basically the same idea as this, then we can just let's run it. Okay, I have an index set up as 1, which means I'm going to be taking it from do it 3, which then transfers it to the playthrough, which then of course, as we explained earlier, how the progression works to the final output stage. We can certainly, if we just want to test this rawly, we can just take this and directly put it to the final output. But this way, so as a workflow type of tip, you can then test various different blocks, introduce them into your animgraph, and if it doesn't work, you can just delete the block and just change your pathway. So in this case, I'll just go as a raw output. I'm going to set my state here to do the animation part of making the player run. So I'll go ahead, compile that up, and if we hit play now, then okay, yeah, great. Okay, so the player is moving based on whatever is being driven through the state machine. Okay, so perfect, key input, what have you, blah blah blah. Messy, messy, messy. So now let's look at it as a blend space input option. So that what we're doing is driving this. So if we change our index from 1 to 0, and we go ahead and compile and hit play, still the same bit of a lag going into it. But I've been playing around with creating my own interpolation brain box, so to speak, but different subject. Identical. This blend space here works identical to the logic block that I built here, so the two are the same. And then we can just take our blend space, drop it into our animgraph, plug it into our pathway, take our playthrough. We're going to plug that back in, and then we can just take our final output pose. We can break that. Oh, stop that. Okay, we'll take our final output stage and we'll just put it back into the pathway again, and then rehook back up all our logic blocks, because we just finished testing. We've confirmed that everything is the same, that do it 1 or do it 0 is the same thing as do it 1, and able to create our blend space and plop that into the stream. And now when we hit play, oh, now it should compile on itself. You can see we can move, and then we can fire. And then we can reload using the action keys. We can jump, sort of. As I said, I haven't patched that part in yet. Let's see. Bindings is for medicate, and etc., etc. So everything kind of progresses like a pachinko machine. You start the ball on the top, and it just goes boom, 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 until it hits the final output stage. No arguments getting in the way or causing any problems. So now, what exactly does in this case, based on this logic, how does this translate into the logic of this particular state machine? How does it translate into actual blend space information? So okay, let's actually pop open a blend space that I have set up, that we've been looking at as far as being driven. Okay, I'm going to be changing this because the logic flow is not really well, I want to have well, different direction, but basically the concept is as you can see, I have the grid set up -1 to +1, which means it corresponds to whatever input that is done by keyboard, and then whatever's being brought in by keyboard can be normalized as a fixed number. So if we start at the center, always into the idle pose. So I'm thinking now, what I'm thinking is just simply getting rid of the idle pose, that blend that has been introduced once again in a fixed point, and just let the blend space handle that type of positioning as a sync to whatever it is that the event graph is generating. So our input state is created by a key binding, S being -1, W being 1, as well as its axis range between left and right, and then of course these are normalized as being positive or negative values, clamped off as to the state that we want the player to be in. So we start in the idle state. Okay, we press W. Okay, what state are we in? Are we actually in crouch? It asks a bunch of questions. Are we in the crouching position? No, so we're not clamping off of that. Are we in the walking position? No, so we're not clamped on that. Are we running? Yes. Okay, so then our value is as we look down in our graph, being just a two-dimensional array. Remember, it's just an array, nothing magical or voodoo going on here. And our index into this is right left 1, run left 1. So that tells us that this is the address of where this particular event is living. And then if we hit the key and and the logic says, are you running? It just goes from idle state, boom, directly over into our right running state, or left running state. Or forward state would be nice to be able to select this. Okay, so in this case, right left would be 0, and forward and backwards would be +1. So as it migrates through it, a position for crouch walking forward would be right left 0, forward backwards 0.25. So then that inputs whatever information can be driven from the key directly. So we hit W. Are we running? Are we walking? Are we crouched? Are we in a prone position? That information is translated as a Boolean within the event graph, which then we can translate that into actual action. Okay, kind of bouncing around there like a little pinball, but everything kind of, it's a connect the dots kind of thing. So once you understand exactly what you can do as far as the possibilities of what a blend space can do, then it opens up a whole lot of options that are available to you that are 100% data driven. That's next gen stuff. Reason why for a practical reason why you would want to do 100% event driven setup is based really on sitting down and pre-planning what it is that you want to accomplish as far as the end result of the game design. So if you want to do 100% of the game code as to inputs and output states, then this type of setup is favors event types of designs as being 100% data driven. A bit difficult to explain. It's so in theory, everything here is driven. It creates the variable that tells the animgraph what to do, and the animgraph can't do anything else unless it's told to do it directly by the event graph. So in this case, we are talking about how I have the blend space set up by index. We can then bring that information based exactly what what it is that the player is performing. So in this case, is the player walking, is the player crouching, and then it is assumed that the player is running as to its final output. So this is where the values become clamped as to inputting that information directly into the blend space, which is in the animgraph. Oh, okay. If you don't understand, watch it a couple times. I mean, I had to watch Matrix 3 times before I actually figured out what the heck was going on. So anyways, we bring that into a sequence, and then we say, and then it's based on a variable. If it's not true, it just simply ignores the value and then moves on to the next value. Question, is it crouching? If it's crouching, then of course it goes up here. It sets the clamp value at positive 0.25 and negative 0.25, and then it's set to the forward and back, and of course our information is the left and right information, and is then set to being positive 0.25 and negative 0.25, and within that, when it's activated within the animgraph, down here it can only perform those two types of positions relative to whatever has been introduced into the blend space. Oh, okay. So anyways, I think that's about as far as I can explain how things works within our flow, our design idea, and we're still very much in the in the iteration phase where we're constantly killing things. We're adding a new, who knows, this whole logic block of a from scratch locomotion state might disappear and change for something else totally different than this. So anyways, I think that's all that needs to be explained about a blend space, what it is. It's simple once you know what it is and how it fits into the grand scheme of things. But until you know what the grand scheme of things looks like, then it really doesn't have that kind of, let's say, bondability to exactly what you're doing. So anyways, that was kind of fun. I might do something. I'll probably do this again when we actually start getting some really serious stuff going. This is just the preliminary. We know that the logic works. We know that it's going to fit within our ideals of what is of a 100% data-driven system, and everything and anything else is just iteration, and almost gets to a point where it's actually kind of boring. Okay, talk to you later. Bye.